let me get to the agenda for today. I'm going to start by kind of giving a bit of a background. So bear with me if you're already familiar with some of the terminologies. I've been to many conferences and I realize sometimes it can be confusing because when you're a developer, you mostly are maybe already working with something, right? You're doing event processing, event messaging. But I think it's good to step back a little bit, trying to understand all of these technologies, terminologies too. I also have another talk later this afternoon on the art and benefits of computing eventfully. That's a bit more generic kind of talk on event computing. But here too, I like to do some introduction on computing events before I get into Pulsar and also Astra, our company's product. So, okay, so that's it. And then also wanting to explain why we want to use event streaming, right? And it's not just doing something cool or fancy or something, but there's a reason, right? The benefits of using event streaming. Then I'll introduce to you Apache Pulsar, and then giving you some highlighting a couple features too. So there'll probably be a lot of information, and then I hope to also show you a bit of Astra Streaming, the managed cloud platform that is running Pulsar underneath the hood. So that will be for today. And okay, let me start. The many facets of computing, right? The computing events. So first of all, I find that it will be important to talk a bit on some basic things, right? What is it that we are trying to do? Why is it that there's computing using the event-driven kind of style? Now, as you know, maybe some of you are aware, right? When we first started learning programming, we actually are all learning things in more of a traditional way, meaning it's more of a request and response type of system. You are having requests to the computing processing behind the scenes. And the thing is, too, is that you need to wait, right? You send a request, and then you wait. You're blocking, right? You're blocking, waiting for processing to be done, and then results come back to you. That's how we learn stuff. And also, too, when we learn, all of the data are kind of simplified. We have data structures and all of these things, and then that's how we do things. But the thing is, though, while it is good, right? And I'm assuming a lot of you are Java developers, you're objects-oriented stuff, and Spring Framework, all of these are great things, but like traditionally, where you, again, doing things the request-response style, doing HTTP, very much, RESTful kind of style. Now, it is great, but if you think about the new time that we're living in, right, is we're living in changing world. We're really dealing with events. Events don't operate like they don't wait, right? Essentially, it's like you come and go. And actually, I wanted to say too, when I come to India, I love it because your traffic system is a good illustration of this event-driven kind of way of doing things. It's very natural, right? But somehow too, that all of these events are happening at different times. Everything's asynchronously, but there's a magical thing that you can't even see it. Everything's working synchronously. Nobody get hurt, that's the thing. Or at least majority of people are okay. So in some ways too, when we're working at events, we're trying to use this mechanism, using it in doing computing. So it's kind of exciting, I think, because it can bring you that real-time benefits. But think of the fact that it is true, in some parts of the world, right? Like where I come from in the US or where I grew up in Hong Kong too, it's like we got traffic system, you need to wait. And because of the wait and waiting for lights to change is orderly, but it also takes time. So it's not as efficient. So that's why too, we want to do things the more natural way, which is an event-driven way. So, okay, so back to what is an event, right? So event, if you kind of look at it, is basically, generically speaking, it doesn't have to be only applying to computing. It can be on anything. It can be your life, right? You have a baby is born is a new event, life event, birth event. Musical concert is an event, a sporting event. But you notice that the event happens and is immutable. That's the key. So in order to do computing too, essentially we need to capture the data that's happening with that event. And so if you look into the definition on the dictionary.com, it will say that, according to the theory of relativity, events are basically a point in time. And once it happens, it's immutable. But that's the amazing thing is that of these, trying to capture it is a very abstract kind of idea. So if you are kind of new to doing event programming, don't give up, because initially it's going to be a little bit counterintuitive. But once you understand, you'll find that it is actually very applicable. It's a very good way of doing things, in fact, right? So, okay, so that's that. So essentially, think of event, kind of basic definition will be, a point in space and time, like 4-dimensional, right? The space, which is X, Y, Z coordinate, and then time component to it too. So it can be any events, right? It happens, it's there, it's not changeable once it happens. Okay, so a bit too, this afternoon I'll be talking a bit more, but I wanted to point out event computing. All of these terminologies we're hearing about today, right? There's event-driven architecture, and today we're going to talk about event streaming, event messaging, event processing, right? And all of these. Then there's also event sourcing, which is kind of a technique that we use if you're familiar to sourcing. It's very, kind of a very efficient way of how do you deal with data that's happening, right? And they can happen at different times too, and that's why it's hard to do tracking and debugging, that type of stuff. So event sourcing, and I won't go into detail now, but I'll talk more later. And then, of course, there's also then the serverless type of application, which is like serverless. Is basically you operate in the cloud, and you actually let the infrastructure handle a lot of the infrastructural concern. Then there's also microservices. All of these are kind of isolating. The idea is you want to decouple sender and receiver of messages. So you make it more flexible and really doing things much more scalable and flexible. So microservices, and there's also one term is here, event storming, which is actually a bit higher level. You're talking about events, you're kind of designing a system, you have a company, let's say a project, stakeholders, everybody coming together and brainstorming ideas. Yeah, those are called event storming. That's also part of this event computing large ecosystem too. So that's what it is. And then, of course, there's also reactive systems, which is a bit higher level, so to speak. If you have come to my talk before, reactive systems, the goals are the same as event-driven computing too, but they are a bit slightly different, but I'll also talk about it more this afternoon. So all these are kind of highlighting the different aspects of event computing. Okay, so now today's talk, event streaming and processing. So now, after a bit of introduction, then if we look into events, they are basically each data point in the system. And so stream, right, as it happens, is that we are doing many things at different times, in space and time. So the streams is basically an ongoing delivery of these events. So the thing is, in order to track the data, let's say you're plotting a graph. So these data points will travel through time, and then you kind of plot them. That's kind of like one example of one stream of data, for example. But the thing is, when we talk about data streams, is many, collection of many events together. That's the stream. Also, the challenging part is asynchronous, and all of these things that comes together, making it challenging. Now, the thing is, of course, these days we are all also watching movies and listening to music. These are all streaming too. So I want to point out too is that when we're using a system like this, it's not specifically for media streaming. Media streaming has a bit of a slightly different requirement because you are listening to radio or listening to music or watching movie. All those frames of data needs to come in order. So that's important, and they need to be processed synchronously. Versus if we're doing event processing, sometimes you can have the packets arrive at different times too, which is different than like media streaming. So I just want to point out. So today's is more about the processing, business data processing versus media streaming. So that's event streaming and processing. And then there's also a terminology that's called complex event processing. So when you think about it, right, data itself is complex enough. But the thing is, the whole point of doing this, we want to capture the data. And we want to add more value to what we're doing, not just capturing the data. So what? The data is here. The idea is that you want to look at the data and figure out if this gets into use case example, maybe fraud detection. You want to have some processes that are monitoring maybe your bank accounts, your financial investment accounts. So you are always all the time is that you have these processes looking at the data, making sure that nobody is trying to break in. There are no hackers kind of trying to, suspicious kind of activities. Those are leveraging on very complex event processing. You're analyzing the data in real time. And that's why, too, it's very important to kind of employ these techniques to help you with that kind of activities. So fraud detection system and also like shopping, like recommendation systems, AI systems, all of these two require real time. So that's when event processing becomes more and more important to enable those kind of systems to do their job in a more complex event processing ecosystem. Okay, so now then get back a little bit more and the basic now. We're talking about back to messaging piece, right? So in terms of messaging too, we are more developers. We're interested in an understanding of some basic terminology. Messaging as such too, there's event-driven messaging and also message-driven messaging. So there are differences too. Event-driven is basically about sender sending messages, and the receiver, receiving side, also can subscribe to these messages. So basically, you are publishing messages, but you don't really care who is going to receive the messages. In other words, you don't need to know the address of the receiver. You're basically letting a middle agent, so to speak, as a broker, right? In a Kafka terminology or Pulsar, we use broker way of doing things. Is the broker will be like, it's responsible for receiving the messages and managing the messages for you. The producer will then be sending the messages only. It only cares about that. And then there are packets of kind of talking to each other, making sure the messages gets delivered and received correctly, right? Okay, so that's sender and receiver not knowing each other is a pub-sub type of way. We describe that as event-driven messaging. Then there's also another way of doing messaging is the message-driven way, which means it's usually is one-to-one, sender and receiver. You have to know each other's address. So much functioning like a queue, right? So the queue, you need to send messages to a queue. You need to know the destination of the receiving. And once the messages gets received, then the messages will be received from the queue. So that's kind of the differences between the two. Okay, so now then back a little bit to about this event approach, right? Versus, if we don't do event processing, actually there's also batch processing that is still widely used. The reason is that some cases, right, is that you don't really worry so much about the timing of processing. For example, system of record, maybe a company, you have employee system, and employees, we change and we move around, we need to update our address. So all those changes, maybe you enter into your company employee system, you collect all of the changes, and you apply all of the changes maybe for the day, in one shot at night. So then you only process that, when the system is less busy. So that's the idea. So basically, what I'm pointing out is that event-driven approach doing things has its own purpose too, but it's also making sure when you are designing your solution for your systems, for your customers, use the right approach for the right kind of situations, right? Some cases you want to use batch, some cases you want to use event-driven approach. So that's that. And now let's get into a bit of the semantics. I already talked about event-driven messaging, but the thing is then it comes to streaming, right? Streaming, very often we're referring to the pub-sub way of doing things. It's an architectural pattern. It doesn't dictate how you should do it. All of the details are up to vendors to kind of decide how they can handle pub-sub. But the idea is that you have clients basically sending the data to a topic, right? A topic will identify what types of message it is, and you let the broker, the middle agent, to own the topic and manage the topic. And then basically, if you're interested in the messages, the clients will need to subscribe to this topic in order to receive it. So then whenever, think of it as consumers like a listener. You're listening to messages arriving in a topic, and the broker will deliver it. Once you have the messages on the topic, then you will receive it on the receiving side. So that's pub-sub way of doing things, and this is just a picture to describe it. Producer produces two topics. You can have multiple producers producing to send to one topic, for example, and so on and so forth. And then you can have subscriber subscribing to the topics, and the broker is the one that's responsible for distributing all of the messages. That's pub-sub. And then there's also message queuing. So message queuing, too, is a form of asynchronous, also like service-to-service kind of communication. Again, it's like you're writing code with Java developer, we write queues and all that. It's the same kind of concept, right? You're doing first in, first out. The queue messages get sent into the queue, and then receiver side will pick up whatever messages that got first kind of pushed into the queue. And then once it gets read by the receiver, then it will be gone. So that's kind of a queuing kind of mechanism illustrated. As such, too, both Pulsar and message queuing, they decouple the sender and the receiver. So with this kind of mechanism, it basically can afford to, for a very scalable system. Like if you have a lot of messages, basically the sender doesn't need to worry about, my job is to just send the messages. So it can, happen in high volume. For example, like Pulsar, you can have 1 million messages within a second. Things like that is because of this kind of mechanism. So it's really ideal to be used, for like event streaming in a cloud system, for example. You need to be very fast. You need to be scalable. So, okay, so enough of this basic thing, but let's kind of take a look to event streaming. Basically, a step beyond just the messaging part. Messaging is just basically sending things back and forth, but the streaming part is what makes it more interesting. It allows for complex event processing. And basically, what is driving the change is basically we want real-time data. It enables you to do things much faster, unlike old ways, right, in which you need to write things to disk and then select back and forth. With this kind of approach, it allows you to process data as it comes in memory like that. So real-time data is driving this change. Then there's also AI and machine learning type of systems, which is demanding even higher volumes of data, as we know. And maybe some of you are working already with AI systems. You know that you are looking at data, many different ways and processing them as they come in. You need to have immediate processing, and you'll be able to update your model right away and deploy it back. So the idea is to use event streaming type of platform to help you ingest all of the high volumes of data quickly. So event streaming is one of the goals, is for helping to build ML and AI systems. And then another thing is basically the scalability aspect too. Again, I mentioned about the way it's working, it allows for high volumes of data to come in through your broker. So for example, like Internet of Things kind of systems too is ideal to be using event streaming. Maybe some of you are also working with IoT like protocol, for example, MQTT, which I work with, right? And they are also using a PubSub type of model, which proves to be very efficient too. So yeah. Okay, so here just summarizing again, right? Why event streaming? It basically allows you to watch for the events with the system or the application. And on the receiving side, you only subscribe to topics of interest. Otherwise, you won't worry about it because you don't waste time, essentially. And you can make decisions on the data in real time, and then allows you to ingest data in high frequency, too. So, and also respond back with low latency. So that's the idea. And this is a diagram that's basically described to streaming, the modern way of streaming versus not streaming. So the top part is basically, or actually, let's look at traditional way. When before we have this modern time streaming system, we basically, for example, like ETL system, maybe some of you have worked with extract, transform, load. So the idea is you still extract all of the data. They are in bulk. You ingest the data. Then you persist it to some database or file system. But as you can see, if you persist data, it will introduce some latency because you need to do disk read and write I/O, right? And then from there, you need to select the data, process it, write it back. So as you can see, it takes longer too. And it's not as fast as the streaming way in which you ingest the data, everything is still in memory, or over the wire, it comes and you process the data right away in memory, so it's much faster. And also you build data pipelines, then it's basically you process the data and you output data to a sink. A sink in which is where you collect the transform data, and then you can continue on this data pipeline. That's the idea. So it makes the processing much faster and also more efficient. Okay, so now let me then talk about Apache Pulsar. So Apache Pulsar basically is Apache project, open source, and it was created by Yahoo back in like 2012, 2013, that time frame. And they basically realized at that point is that they were starting to use Kafka. Kafka was started by LinkedIn too, you may be aware. And then they were using Kafka. Well, while Kafka is good as a distributed messaging broker and everything, it's not able to handle the cloud, operating in cloud as efficiently. As you may know, if you are a Kafka user, you actually have to rely on external ways of helping you. If you need to add a node to a cluster, all of these things, you need to write your own code and expand, right, your ecosystem. You need to rebalance your topics. It's a lot of work, especially as developers. We have to become kind of a bit like operators, kind of operation. So that's when Pulsar was born. They decided, well, we want to write a true event streaming platform that can operate in the cloud and takes care of these cloud concerns. So then, it became quite successful, and in 2016, they donated it to Apache Software Foundation, and then very quickly, in 2018, that became a top-level project. So as we know, and Apache do so many projects, but this one really is rising in significance too because of its capability. So among the features, I want to point out is it has a cloud-native design. By design too, it's already, the Yahoo folks are like, we want to design a system that can handle cluster-based system. And also too, there's a feature called multi-tenancy. The multi-tenancy allows you to have messages already naturally being grouped according by different unit of operation, which they call tenants, right? It's like an apartment building. I always like to use this example. You can have messages kind of all organized. For example, in a company, you could have finance department that messages is that, and then you have accounting messages and engineering messages. So naturally, it already comes with that, this multi-tenancy. And then also, too, when you work with it, you're writing code, you're either writing producer code or writing receiver consumer code. So all these two is not restricted to only Java. The broker itself is a serverless Java JVM process, but to write clients, you can do it not just in Java, you can do even C#, you can do Python, Go, and any other community contributed client APIs too, which include like Scala or Ruby, all these others too. So quite flexible. And also another feature of Pulsar that's kind of, I think too is an important feature is that it separates out the compute and the storage. As we all know, these are messaging systems. Messaging, right? Like it's easy to say I send the messages, but what to do with the messages after you send it, right? So you need to, in some ways, you want to allow these messages to be saved or to be looked up later. All of these, it becomes like a laundry basket, right? It's kind of all these messages, they comes in millions, trillions. So Kafka itself too doesn't have this mechanism. You will have to use Kafka's way, they manage all of these messages. But Pulsar said, well, I'm not going to deal with this laundry basket, so let me use another helper. So the helper is actually Apache Bookkeeper project. So that's another project, and Bookkeeper itself too is an efficient way. It helps you as such. Bookkeepers like do bookkeeping. So it handles all of these messages as fast read and fast write, very efficient, and also kind of guarantee integrity of the data, all of these things. So basically, Broker is running. Broker also has different ways of managing, this huge like set of log messages. It's all like segment off. They call segmentation. Is Bookkeeper way. So if you're interested, you can look up Apache Bookkeeper project. Is a project of itself too. And at DataStax, we also have Bookkeeper project committer working on that too. So okay, so that's Pulsar. So as you can see, then Pulsar kind of basically separate out, right? So then Pulsar, in this case, only worries more about being the broker. Being the broker is already busy enough. You're receiving messages, then you have to process the messages. Each message comes to, sometimes you have different parameters, like how long should the message live? What if the message doesn't get delivered, right? All the retry mechanism by itself is already complicated enough. So Pulsar has all of these things built in, like deduplication, chunking. If you have huge messages, like in fact, I got asked and people were saying, oh, I have like a gigabyte message payload. In that case, there's also chunking that it helps naturally breaking it down into different chunks too, and it does reassembling too on the other end, for example. So Pulsar has all of these things it does too. So it separates out the compute and storage. Okay, and then another thing too with message delivery part is that you want to guarantee, right, that messages get sent, but how do you know it gets delivered, right? So Pulsar already has built-in mechanism like the quality of service too. It guarantees if you send, I'm a producer, I produce a message, send it to the broker. So already have identified topic, it's saved. Once it's there, if something goes away, don't worry about it. Everything is in a cluster, then it will be delivered. Once a cluster, say a node is down, don't worry, it's already there. When this kind of comes back up, it knows it. The broker will go and take care of things for you and deliver the messages. Maybe a little delay, but it won't be lost, in other words. Okay. Okay, and then there's another feature to a Pulsar that's kind of nice too, which is called a serverless functions transformation framework. And now, as we talk about event messages coming in, the messages is not just carries so much data, but a lot of times too, we want to do some sort of transformation on the data. Maybe you want to filter some messages, wanting to do some selection, only certain messages get passed on, for example. So then you want to do some transformation. So basically, too, Pulsar is kind of borrow the idea of something like AWS Lambda, the serverless type of function framework. So Pulsar has this serverless function framework called Pulsar functions. And also, too, is also called transform functions, which is a set of predefined, pre-configured, commonly used functions as well. So Pulsar has this capability so that you're building your data pipeline, it travels through, it goes through, and you can use the function framework. You can write your transformation function quite efficiently and not worry about what to do if you had your cloud system is going to add another node. You need to increase capacity of your cloud system. Don't worry. You just write your functions. We'll take care of business for you. So that's the Pulsar functions. And then there's also one more feature that's worth mentioning is the tiered storage offloads. As we know, messages comes in, and some of them too might be messages comes in and it's becoming cold and it's taking up space. So Pulsar also knows it and then immediately will say, well, you guys are inactive for a while, so I'll move your set of messages to offload storage, such as like S3 buckets, in a cloud environment, or like the Hadoop file system that will actually cost less money. So you can kind of configure it too. So it has this feature called tiered storage offloads too. So those are kind of highlighting the Pulsar capability. Okay. This one, too, is just basically showing you that Apache Pulsar is gaining in popularity. The number of GitHub stars, if you go to the project in GitHub, number of GitHub stars keep rising. Number of contributors also keeps rising. And also, it's actually, in 2021, that was the latest statistics, almost 2 years ago in June, then even number of contributors have outpaced that of Kafka contributors as well. So people are recognizing its importance. So that's that. And also in actually 2022, it's actually one of the top 5 projects too. Yes, quite recently. So it is becoming an important project. And then you may be wondering, who else is using Pulsar? So these are just a handful. You may or may not recognize some of them, but Yahoo and Splunk, and again, right, because it's originally developed by Yahoo, so the Yahoo engineering team is also still using it too. And Splunk and Verizon, a couple of companies in Asia, in China too, they are also big supporter and users of Pulsar. Okay, so how is Pulsar different? Just wanted to kind of give you a quick kind of introduction again. If you think of Pulsar, it's basically there are 5 components to it. One is the producer. You are the one you have to write the code to do sending of messages. Producer, and then there's consumer is the one client application to consume the messages. That's 2. And then broker, as I also already mentioned, is a stateless JVM process. It manages all of the messages that comes in and the message dispatching, and also have broker talk to the bookkeeper. Bookkeeper is the actual one, right? The next one basically helps with persisting the message store. So it manages that, but it's the broker that kind of communicates with the bookkeeper. And then also there's Zookeeper is involved. The Zookeeper is there to help with managing the metadata, the cluster, all of these things. So these are the 5 kind of main kind of components of a Pulsar system. And then if you kind of take a look, that diagram is showing you kind of conceptually too. You can have multiple brokers, and very often in an ecosystem like this, you usually use multiple brokers because it helps with like the overall throughput of message sending, all of these things. And also the storage too, over here, right? The Bookie, as you can see, Bookie is the one that manages all of your log messages. And basically it segments off too. So it kind of allows for easier reading and also writing too. So that's, if you're interested, you can always look up the Bookkeeper project to look at more of the information of that too. Okay, and then also a bit of a pointing out to you design principle, right? And of Pulsar, it takes up like a tiered architecture type of design too. So it's a traditional like multi-node architecture, and it supports like horizontal scaling. It's the case in which you need to add in more servers or nodes to your ecosystem. It's basically, it knows, Pulsar is already built in to know that if you add in another node or server to your infrastructure, right, your cloud infrastructure, then some of them, for example, your topics too you may define it to live in different partitions. So in that case too is that Pulsar knows it and it will rebalance all of your topics for you. So in other words, over there, if you think of adding another broker, adding another storage in there, it knows and it will balance it out. So then you don't need to manually worry about it. So that's the idea. So over there, okay, and here. Here too, then this particular slide probably is kind of a sort of already talked about earlier in there, but wanting to highlight is basically the bookie part. So bookie itself too, again, is very scalable. It's also this specification called WAL, W-A-L, is write ahead logging kind of based. And it's also fault tolerance too by itself. It has its own mechanism of managing all of these messages, low latency too. And you can tune that consistency for message replication, all of these things too. And also it manages all of these messages using their own ledger system. So it's kind of like accounting, they call it ledger system, and manages all of your messages kind of in different segments too. So it's kind of has its own way of managing. It's quite efficient is what it is. So over here too is just conceptually telling you why you might want to consider using Apache Pulsar. Because it's essentially too, we're proposing it as a unified solution. For like PubSub, you want to do PubSub, it has PubSub messaging. It's actually also support queuing, but I'll quickly show you how you can kind of use Pulsar as like a queuing too by basically have dedicated topic to only one subscriber. In that case, you turn Pulsar into a kind of a queuing kind of capability too. And then also, of course, you use it for streaming. And also, too, if you want to transform data, messages that comes through, like enriching your messages, like I mentioned, you can use Pulsar functions to help you without using any external library to help you to do it, too. And then the idea over here is just showing you is this diagram, as you can see right now, right? Pulsar, too, runs on the major cloud providers, AWS, this here, Google Cloud and also Azure too. There are also other clouds too that it runs on as well. But the idea is that if you are already, in your company, let's say you already are running Kafka or JMS or RabbitMQ, you already have invested those time building those infrastructure, you don't need to throw them away. The nice thing about this is that you can use Pulsar sort of as a bolt-on thing because of the way you do data pipelining, all of these. You can actually kind of nicely have Pulsar fit into your ecosystem. And specifically, too, at DataStax, too, we have what we call like Starlight API layer. So basically, Starlight, we have it configured to work with Kafka, basically using the Kafka protocol. So you can use our API to talk to Kafka. And then also, it supports also JMS too, Starlight for JMS and also Starlight for RabbitMQ. So we have these kind of API connectivity to help you to integrate with maybe older systems. So then you don't need to throw old things away. We basically are very friendly kind of feature. We come in, you can just use us and we can help you enhance your ecosystem. So that's the idea. Okay, so this is just another diagram just describing. It's a very unifying platform. We like to say that you can use Pulsar in your existing ecosystem. This is a little small here, but if you get my slides, you can look at it in more detail. You can, in today's kind of complex environment, right, you can be running many different things. And basically, if you have the right kind of interface, is basically you can put Pulsar in the middle, like a unified message broker, a hub too, like that. So that's that. And oh, sorry. Okay, so now let me kind of real quickly then step through there, just some differentiator. I talked for a long time, but let's summarize again why we want to choose Pulsar. So first, right, it's basically, I already talked about separation between compute and storage. As I talk about, right, and because we are using Bookkeeper to manage all of the storage of all of the log messages, and this is a tiered architecture, so it's actually make this whole operations, the mechanism to be quite efficient too. Quite efficient too. So again, right, if you separate out compute and storage, then the broker itself can focus more on the messaging side and let Bookkeeper handle the complex logging, that whole logging stuff. You basically, the broker will just communicate with the Bookkeeper, if any time your applications needs to look up some log messages that look back in history, doing history replay, you can actually, we have APIs that allows you to do that. There's a reader interface. You can go in, and then basically it can search messages for you as well. So that's that. That's one, separation between compute and storage. The second thing, too, is that with Pulsar, is that it also supports like geo-replication. Maybe some of you are involved, too, with your company's ecosystem. There, you can have data center, right, that are in different parts of the country or different parts of the world, and you want to be able to have replication being done among your different data centers. So the nice thing about this is that Pulsar already has that built-in mechanism that you can do a selective message replication. Because maybe sometimes, right, in different regions, you have different sets of rules for the data, what is to be transferred or not, that type of stuff. So you can configure it too. And then it has different like replication mechanism if you are into those things. There are synchronous versus asynchronous or active-active pattern, selective message replication as I talk about. For example, in Europe too, there's GDPR kind of privacy data. You don't want certain data to be replicated, right? If it's a European data center, you want to keep it there. That type of stuff, you can use the message replication to configure it, that type of stuff. So geo-replication is another really nice feature that comes with Pulsar. Okay, and then I also mentioned already is the multi-tenancy. This is just a diagram to describe it. Think of a cluster. You have different messages that flows through, but you basically can organize your data into different, segment them off, so to speak, tenancy, like different tenants that manages, different namespace within it. So basically, in this case too, it helps you to manage it, to manage all of your data, sort them out already. It's built in there. So yeah, so that's also one kind of good thing about considering to use Pulsar. And then there's also this one. Okay, it's a very flexible message processing model. This kind of comes to the subscription side. It's basically there are 4 different subscription mode that you can use, from the perspective of a consumer. You can have an exclusive consumer mode, and that will mean that one topic can only have one subscriber to it. For that subscription, it's exclusive. So in that case, you are kind of like turning this particular connection to be like a queue, like a message queue. The message arrives only kind of destined for one consumer. Think of it that way. It's exclusive. And then there's also cases in which you want to guarantee, there's the messages don't get lost, and you can actually have multiple subscribing to a topic, but only one access the primary. So that's a failover type of subscription. And then the third kind is basically a shared type of subscription that allows you to have multiple consumer for a subscription too, and that's shared. However, the shared mode doesn't guarantee your message ordering. As you know, sometimes some applications you do want to guarantee the order of the message as it comes, how is it delivered. In that case, then you might want to consider using a key shared kind of mode. That will guarantee that you have multiple consumers, but messages comes, they will be delivered in the order as it is being received. So these are like the 4 different modes of subscription that you can use with Pulsar. Okay, I know there's a lot of things. So just highlighting a couple more developer features here. Again, let's kind of go back a little bit, right? We talk about a lot of things from events, all the way now to all the data. So the idea is that it allows us, right, as developers, and maybe some of your data engineering teams, you want to build data pipelines, right? So data pipelines too, let's kind of look at it this way. We're looking at data, it's like water flows through faucet, right? That kind of goes through and needs to be processed, like a processing area. And then when it's done, it flows into a sink. That's the idea of the data pipeline. You can apply these techniques to doing data science applications, machine learning, AI type. Now, the key is that the data comes in, then this part is basically transformed. You can do message enrichment, remediation, do analysis, all of these things. And this is where, essentially, that's where Pulsar, the functions, can come in to help you transform the data. Okay, so in terms of Pulsar too, is that we have Pulsar functions. As I mentioned earlier too, this is a feature of Pulsar. It allows you to kind of process the streams, kind of complex stream processing. But the thing is, for you to write the code is relatively lightweight, because all you need to do is implement the Pulsar functions. And then it kind of functions like AWS Lambdas or working like Google functions, that type of concept. You don't need to use any external library or write your own functions to deal with that. So you can basically have your functions written and deploy it to Go. But right now, it's only supporting Java, Python, and Go. But it's, as such, it's open source. So there will be more language support eventually, too. But that's the idea, right? You can have different input topics coming in to the messages, and you process by Pulsar function. And from the function, you output the messages to a sink. But the sink can actually be another topic that can be turned into another input topic for another pipeline too. That's the idea. But you can also have the transform messages to become, to write to a log too, for log messages as well. So over here is another example in here. So that's Pulsar functions, kind of quickly explained to you. Then there's also another feature called Pulsar schema. So as you know, right, we're dealing with messages. Messages has to, all distributed type of ecosystem that goes over the wire. But the thing is too is that by default, if you don't specify the type of messages that goes over the wire, Pulsar will expect it to be byte array. So we all know that in today's complex environment, we want to have some ways of managing our schema because your schema keeps changing all of these things. So Pulsar has a feature called Pulsar schema too. As such, you can actually use types such as primitive types for your schema, for your data, or key value pair, or frow, JSON, protobuf too. So this is what Pulsar schema can support, all of these different types. And think of it more like a registry. You have data that needs to go over, to send over the wire, and think of it as like managing a registry, managing your data, and then if you have any changes, it will track the changes for you. So in other words, think of like a version control of your data, your payload, to it manages that for you. So, and also it keeps track of different versioning and guarantee compatibility. You have to design it properly too, of course. So you can think of using Pulsar schema instead of having had to convert all your data to byte array. So that's another feature. And then another feature too is basically we talk about data pipeline. So it allows you basically to build your own source connector. As you see, right, we have the source of data coming in, ingesting data. Source can be anything and can be like Kafka. Source can be another database and any kind, right? Can be like any service as a platform type of thing too. Any data coming in, you kind of basically use Pulsar and utilizing the functions to transform your messages or enrich it, then the output will go into a sink. That's the model we're using in here. The thing is that right now with Pulsar, it has over 100 different already pre-configured connectors, can be source or sinks. But let's say you have some things that you want to plug it into your architecture, and you can't find a pre-configured source or sink, you can actually write your own source and sink too. And basically using the Pulsar I/O, it has a set of APIs that allows you to do it too. So that's the idea. But I do have to admit, Pulsar, as such, it's still kind of a young project, so do expect a bit of hiccups, right? And my understanding is that we have some customers that try something out, it doesn't quite work. But the nice thing is that with, for example, DataStax, our company is a young company, our streaming team, we are always very excited to be pairing with you and helping you out too. So that's the idea. Okay, so now, real quickly telling you about DataStax, my company. We support Pulsar, and essentially I mentioned about Astra Streaming, that's our managed cloud platform. The nice thing about this is that if you use our streaming, then of course, just like any service on the cloud, and you don't need to manage it. So I'll hopefully my internet works good, I can quickly kind of connect and show you a few things. And the nice thing is that with our Astra Streaming, we are offering everybody a free kind of beginner's account, and you can use like up to $25 US dollar per month to build your own projects too. So, and I'll give you the link and you can sign up. There's no need for a credit card, just your email address too. So I'll quickly show that to you shortly. Now, let's say, right, some companies, they don't want to get into using cloud yet. I've come across customers that they are still not in the cloud. So in that case, you can use Luna Streaming. Luna Streaming is basically you deploy to your own Kubernetes cluster or your private cloud, all of these things. But in that case, you have to manage your own, a lot of things, right? You have to manage on your own rather than letting your cloud platform manage it. So you can use Luna Streaming. And then, of course, the third choice is basically use what you can find in Apache Pulsar project. You download it and use the open source project as well. But again, we at DataStax, we have committers on the project. We're always there to help the community is quite friendly too, so to speak. So, okay. And then here, I already mentioned, but just summarizing it again, Pulsar. Think of Pulsar, right? It's like the messaging substrate in here. You can use Pulsar, use the native messaging, or you can, if you need to connect to RabbitMQ, connect to your Kafka, connect to JMS, you can use our Starlight API layer to do that too. So that's that. Now, this kind of particular diagram is just a summary in pictures of all of the different source connectors and client connectors, source and what you call sync connectors in here. So there are different databases. A lot of the common databases are supported, like Oracle, MariaDB, MySQL, JDBC, all of these, a whole bunch of them. And then there's also messaging and streaming workflow systems like Kafka, like JMS and MQTT. All of these are also supported too. And then there's also like service as a platform, or what is it, a service, software as a service, right? And like Twitter, for example, these already have built-in pre-configured connector. And there are increasing number of connectors too that the community is contributing to. Monitoring like Splunk, Datadog, and also the languages and clients, as I mentioned, you can have Java, you can have C++, C#, Visual Basic, all these, Haskell, Scala, a lot of them to our community contribution too. Okay, let me make sure my time. Okay, so now let me try to get to quickly to, let's see, hopefully the internet will work good enough, and let me really quickly go to here. You can see, okay. You go to HTTPS, actually I should have, astra.datastacks.com. Yeah, sorry, I know it's kind of hard to see. Maybe a little bit slow right now. Like I said, the internet, I'm using the hotspot of, let's see. Okay, if not, let me, okay, let's that. Let me, actually this, I think I have this one. Yeah, the internet, it's just, okay, there we go. So you will see this screen. It's basically DataStax, the Astra. It's still called Astra DB, but it's actually our Astra platform, right? So, but it has this database, which is the Cassandra, or you can use streaming too. So over here, if you want to sign up at the bottom here, you can sign up over here. And again, all you need is just your work email and your, doesn't have to be really work, just an operating email so you can receive communication and just set up your account like that. No need for a credit card. But in my case, I already have an account, so okay, let me do it again. So I'll sign in with my Google account. You can see okay, right? Yeah, okay. And also, actually, before I forget, I do have a Twitch stream too. It actually might be easier. I can share with you my Twitch stream. Once I'm back, not traveling, I usually do my Twitch stream and I can do more demo. That way it's easier for you. But for now, just to kind of quickly show you. So here too, I know it's a little harder to see, but as you can tell, right, on the left side is that column of showing you our data stacks, and you can set up different like organization. It's basically, maybe you want to set up different projects and you set up kind of different units of your experimentation. You can do it in there. And then, which is very nice. And then you can have database, again, right? If you want to play around with our Cassandra, you can create the database as easy as just create a database and then give a few things, your namespace, and then boom, your Cassandra database is up there. But today we're talking about streaming. So let's go over to streaming. So in order to work with our streaming, it's as fast as if you want to create one. Let's say I want to create a tenant and call this tenant like gits1 or something for today. And we use Google Cloud. And let's use, this is Asia, let's use Australia. And as you can see over here, it shows you the operation cost too. And the $25 US dollar is actually quite sufficient if you're doing smaller experimental project, let's say for a month too. So $25 is quite sufficient. Now, the thing is, if you are let's say a startup company, you're interested in actually seriously using our product, we have support too, that we can get you additional credits to work on your project. So that's a nice thing. But otherwise too, all you need to do is just say create a tenant, and then it's pretty fast too. Gits1 is up here, and then you can then click on Gits1, and this is a very nice kind of feature. That's why I want to share with you, because you'll be right away, you want to go back and try things out. Immediately, you can create this streaming, like a stream, managed stream on our Astra streaming. And let's say we're Java people, so we want to kind of take a look. And then you can just kind of look into the code example. It gives you example of how you can use the Maven. What is the definitions to use, and how do you connect using Gradle is all there. And then how do you write a producer? You can just go into here. And it's very simple too. If you're a producer, you want to connect, all you need to do is set up your client builder. And of course too, you need the URL, all of these things, right? For your broker URL, your Pulsar admin. Pulsar admin connects as an HTTP connection. So you need a different URL. All of these too. In fact, let me kind of quickly show you. You go back to your newly created streaming cluster. And actually it's here. Connect, sorry. Go back to connect, and there's a download client.conf. And client.conf will contain the files, a file that has your connection URL, all of these things in there. So you can then use that. And then you can reference here, right? How do you write a Java client to write a producer? And all you need to do, very basic, is that you set up your client handle and then basically do a new producer, have it associate with the topic, and then once it's created, you can then start sending messages. And as easy as producer.send, and that's a synchronous send. You can also do producer.async send, that would be asynchronous send. And then we always remember, if you not using Pulsar schema, that you have to convert it into byte array. So once you do send, the messages get sent like that. It's as fast as that. And then if you want to consume it, right, you go to the consumer code. Consumer works kind of similarly. You want to set up your client builder, get all the authentication. Once your handle is there, then you basically can create your consumer and associate the consumer with the topic to receive messages from. And then set up the subscription name. And then in that case, then you are ready, act as a listener. So when their messages comes, you want to write code in which you can acknowledge it. You receive the messages and you acknowledge. The acknowledge will send to the broker, telling the broker, okay, I receive it. The broker will then remove it from the queue, internal queue for you, kind of like that. So it's as simple as that. If you want to kind of get some instruction, this is how you can quickly start with our S3 streaming. I really like that, and it doesn't cost you any money. And then there are other things too, like CDC is the change data capture consumer, also is in here, and also a reader interface, as I talked with you about. Basically, this will help you to navigate through your bookkeeper, all of the log messages too. You can use the reader interface to do. So, okay, I think I have a couple minutes left, so I mean, we'll quickly go back and just wrap up today's. And okay, let me do that. Here, so just some appendix and resources on the slide deck. How do you look up Pulsar, Bookkeeper, Zookeeper, and our data stacks: AstraDB, Astra Streaming, Luna Streaming, CDC is in here. Yeah, and then also some community resources if you want to, because it's open source project behind the scenes. So you're welcome to follow, sign up with Slack, and if you're interested, right, and get to look at the source code on GitHub, Starlight for JMS, all of these things is also there. And then, as I mentioned too, if you're interested to have more credits, right, you can also use this link and talk to us too, and we can help you if you are running a small business, right? You want to start, we're always there to help you too. Okay, and then we also have on YouTube 5 minutes about Pulsar, little bite-sized kind of information that you can look at on YouTube. It's also all free. And here too, my Twitch stream, as I mentioned about, I have actually done a couple of them before, but lately it's been busy, so I haven't been running my Twitch stream. But otherwise too, you are welcome to participate, interact, and I can invite you to my stream if you're interested too. So yes, it's very flexible, yeah. Oh, this one doesn't come out good. But anyway, for data stacks too, we have a site called Awesome Astra. It's just example code that you can look at too. So if you go to this github.io link, and you can get that too. Okay, and then just one benchmark report. If you're curious about Kafka versus Pulsar, there's a company called Stream Native. They are the original Yahoo engineers from the Pulsar project, and they are at that company, and they've done a benchmark to measure Kafka and Pulsar, certain test cases. So if you're interested, it is here too. So, okay. And then with that, I want to thank you very much. I think I'm just kind of on time for the 1 hour. Thank you. Thank you.